Okay, so imagine this. Imagine, just for a second, that you're trying to find one specific, totally unique grain of sand, and it's hidden somewhere on one of the thousands of beaches on Earth. If you used a normal, classical computer to help you find it, that machine would have to check each grain, one by one. Even if it was checking millions of grains at a time, it would take absolutely forever. But now, imagine a machine that could check every single grain of sand on the planet simultaneously and just hand you the exact location in seconds. That's not some wild concept from science fiction. That is the raw, reality-bending power of quantum computing. And it's about to completely transform the world of artificial intelligence in ways most of us just don't fully grasp yet.
Welcome to The Explainer. If you've been hearing the terms quantum computing and AI thrown around together lately and kind of felt a bit lost, hey, you are in exactly the right place. Today, we're going to completely demystify this incredibly complex topic. By the end of this, you're going to understand exactly how this mind-blowing technology actually works. So let's dive right into our simple 5-step roadmap. We'll start with the AI computing wall. Then we'll break down bits versus quantum qubits. Third, we'll look at solving the unsolvable, followed by supercharging artificial intelligence. And finally, we'll wrap up with some actionable quantum computing career paths. Let's get to it. Section 1, the AI computing wall. Basically, physics ran out of room. To really understand why we even need a new type of computer in the first place, we have to look at the massive problems staring us in the face right now. See, we've spent decades making our classical computers faster, but physics has literally run out of room. The massive large language models powering those incredible tools like ChatGPT, they need to crunch through billions of data connections just to learn. Because of that, training the biggest AI models today takes weeks. It costs millions of dollars. And get this, it consumes as much electricity as a small city. We're hitting a massive return on investment bottleneck. Modern AI models are just getting so incredibly complex that even our absolute best, most cutting-edge microchips are really struggling to keep up. Moving to Section 2, bits versus quantum qubits. We're opening up a whole new rulebook here. Here's the thing, quantum computing doesn't just give us a slightly faster version of the laptop you already have. It plays by a totally different set of physical rules. Every phone, laptop, or server you've ever used stores data as classical bits. Think of a bit like a light switch. It's either precisely off, a 0, or it's precisely on, a 1. It tests options linearly, one after the other. But quantum computers, they use qubits, or quantum bits. Think of the qubit not as a switch, but as a spinning coin. While that coin is spinning in the air, it's neither heads nor tails. It's essentially both at the exact same time. The moment it lands, sure, it picks one. But while it's computing, it operates as both. And that spinning coin analogy brings us to our first crucial quantum definition, superposition. Superposition is just the ability of a quantum bit to be both a 0 and a 1 at the exact same time. So why does that matter? Well, think about your car's GPS. If a classical computer is trying to find you the best route across a busy city, it calculates one route, then another, testing each path one at a time. A quantum computer using superposition is like a GPS that can explore every single possible map route at the exact same moment. Now, let's add a second, truly mind-bending concept into the mix, entanglement. This happens when two qubits become linked together. Once they're entangled, whatever happens to one qubit instantly affects the other. And I mean instantly, completely regardless of physical distance. They could literally be on opposite sides of the planet, and they would still react simultaneously. This incredible link allows quantum computers to coordinate massive, highly complex calculations way, way beyond anything a classical machine could ever dream of handling. Now, if you're sitting there thinking this sounds like straight-up magic, you definitely aren't alone. Even Albert Einstein was completely blown away by entanglement. He famously called it spooky action at a distance. It totally defies our everyday common-sense understanding of reality, but it is a proven physical phenomenon, and engineers are actually harnessing it right now to process information. Okay, the final piece of this puzzle is interference. Because a quantum computer is exploring so many different paths all at once, it obviously needs a way to pinpoint the right one. So quantum computers use interference to amplify the computational paths that lead to the correct answers while automatically canceling out the paths that lead to the wrong ones. A really great way to visualize this is to think of interference like a pair of noise-canceling headphones. But instead of filtering out annoying background noise, they're filtering out all the bad mathematical solutions. All right, Section 3, solving the unsolvable. We are moving way beyond classical steps. So how do all these abstract theoretical concepts actually translate into raw computing power? The sheer scale of the difference here is staggering. Back in 2019, Google hit a massive milestone known as quantum supremacy. They built a quantum chip that successfully solved a highly complex problem in just 200 seconds. If you took that exact same problem and gave it to the world's fastest, most powerful classical supercomputer, it would have taken 10,000 years to solve. 200 seconds versus 10,000 years. That's not just a software upgrade, folks. That is an entirely new paradigm of computation. Section 4, Supercharging AI. This is where we completely change the game. And this brings us right to the impending collision that's reshaping our future. At its core, AI is fundamentally just a massive math problem, and quantum computing changes the game in 3 massive ways. Step 1 is faster training. Remember those AI models we mentioned that take weeks to train? Quantum-accelerated systems could potentially condense that down into mere hours. That means incredibly powerful AI built faster, with a vastly improved ROI for businesses. Step 2 is solving unsolvable problems. We're talking about cracking entire new categories of data that classical computers just can't even touch. And step 3 is an exciting new frontier, quantum machine learning. This involves using quantum computers to train AI models that are fundamentally different. They're vastly more efficient and capable of learning from far less data. This could literally democratize AI, putting it into the hands of smaller companies who don't have billion-dollar server farms lying around. But what does this mean for humanity? Why does this actually matter to you and me? Because these machines are uniquely suited for problems with trillions of variables. Take drug discovery, for example. Simulating how a single medicine molecule behaves depending on temperature and its environment, that would take a classical computer longer than the age of the universe. Seriously. But quantum computers can simulate this effortlessly. We're looking at real-time climate system modeling to predict weather with perfect accuracy. We can achieve absolute global supply chain optimization. We could even see full molecular brain simulation, unlocking massive breakthroughs in mental health treatment and personalized medicine. It's truly incredible. Section 5, Quantum Career Paths. Let's talk about the massive talent gap. If you're wondering how to get involved in all this, listen closely. The industry is absolutely screaming for talent right now. Let's look at a concrete blueprint for your career. If you want to go the technical route, a background in physics or math is a fantastic start. Python is absolutely the essential programming language to learn here. And you can actually start experimenting today, for free, using online quantum computing frameworks like IBM's Qiskit. Oh, and linear algebra? That's the core math you'll need. Now, if you prefer the AI side, your classical machine learning skills, understanding of neural networks, and data pipelines are still completely relevant. They basically just add quantum on top. And importantly, there are massive opportunities in non-technical roles too. This industry desperately needs communicators, ethicists, and product managers. Someone has to explain this wildly complex technology to governments and CEOs, right? If you can understand the basic concepts we just discussed today, you are already well on your way. And the return on investment for learning these skills? It's astonishing. Because the talent gap is so incredibly massive right now, there are far more open jobs than people to fill them. Check this out. Right now, the average quantum computing engineer in the US earns between $130,000 and $250,000 a year. Tech giants like IBM, Google, and Microsoft, alongside really cool startups like IonQ and Rigetti, are racing to build these systems at scale, and they are more than willing to pay top dollar for anyone who understands how to operate them. So the absolutely crucial point is this. We are standing at the very beginning of a technological tidal wave. It's kind of like looking at the internet back in 1993. The companies and individuals who take the time to really understand quantum computing today are going to have an almost unfair advantage tomorrow. Quantum computing is the key that opens up the next 100 years of human progress, and AI is going to be its biggest beneficiary. So I'll leave you with this final thought to ponder. When physics is no longer the ceiling, what will you build? Start learning, start experimenting, and most importantly, stay curious. Thanks so much for joining me on this explainer, and I'll catch you next time.